So I want to give you the idea of matrices as a function. They have to take an input. So here's my favorite 2 by 2 example, right? 1, 2, 3, 4. Okay. And this is going to take a vector as an input. So this vector is a 2 by 1 vector. What's the result of this multiplication going to be?
2 by 1.
Perfect. It's going to be a 2 by 1 matrix, right, which is really a vector itself. You guys see that? So this thing, right, my 1, 2, 3, 4, 2 by 2 matrix, has a function, takes in vectors that look like this, right? And what does it output? Yeah, 2 by 1 vectors. Vectors that also look like that, right? Are they the same vectors? No, probably not. Are they related to the vectors that I put in? Yeah, definitely. You guys see this? If I do this multiplication, this is going to look a lot like something we did in maybe algebra 1 or 2. So if I do this multiplication, what do I get? What's my 2 by 1 result for applying 1, 2, 3, 4 to xy?
X plus 2y,
Okay.
3x plus 4,
3x plus 4y.
y.
Right? Good. Do you all remember an algebra 2 situation in which something like this was used? Yeah, those kind of look like lines, right? If they were equal to numbers or something, they would be lines. So have you guys ever seen augmented matrices before? What's an augmented matrix? Is it, so how many of you is this totally new for? Oh, cool. All right, so let's learn a new thing. So an augmented matrix is something like this. I have a sort of a regular matrix, right? So my favorite regular matrix. And I choose to augment by something. Okay. So in this case, I'm going to augment by 5 and 6. Is that going to make my numbers horrible? Probably. Okay, so you'll have to bear with me because the numbers might be horrible here. What I mean by this thing, when you see one of these guys, what I want you to think is an equal sign. So I want you to think about this as x plus 2y and 3x plus 4y. And these are going to equal what? 5 and 6. Okay, see that? So an augmented matrix is just a fancy way of writing down a system of little equations. Okay, see that? Augmented means added to. So here I'm adding to this matrix by this vector. Yeah, kind of enhanced, right? So the thing that's actually happening here, right? And we didn't talk about this in Algebra 2 if you had this in Algebra 2. The thing that I'm doing is I'm really saying, hey, if I take the 1, 2, 3, 4 matrix and multiply by some vector x, y, apparently I get 5, 6 out of that. What's the obvious question from something like this?
What are you multiplying to get those?
Perfect. You guys see that? Yeah, they're probably horrible numbers because I just made this example up, right? But that's the question, right? Is where do those two lines, right? These are two lines. Where do those two lines meet? That's going to be a point, right? Or it's going to be they don't meet or they're always the same. But generically, that's going to be a point. That point is going to have x and y coordinates. That's what this number is. You see that? So that's why it's a function, right? If I put in an x, y, I'm going to get some intersecting or some values out, right? You guys see that? So the other question was of interest to us in Algebra 2, where we did this like, okay, I want to know where those two lines meet. What x and y do I put in to get this to happen? In the last couple of days, we've just been doing feeding vectors in to matrices, right? So what we've been doing is the other direction, right? We've been evaluating functions because we've just been multiplying a matrix by a vector. This question is about solving. See that? Cool. So augmented matrix, these guys are a solve tool. Matrix multiplication, like, okay, I'm going to take 1, 2, 3, 4, and multiply by, oh, I don't know, what's your favorite pair of numbers?
73.
Good answer.
Yeah.
Okay, right? This equals question mark, right? This is an evaluate type question. You guys good with this? Hold that? Maybe, kind of, ish. Okay, so from a function perspective, right? I have my function 1, 2, 3, 4, which is kind of complicated. But what it does is it takes 2 by 1 vectors and turns them into other 2 by 1 vectors. Which in this case, I can think about as an intersecting point and some constant. Right, that's adjusting the y-intercepts of those lines. You guys see this? Kind of maybe-ish? All right. Yeah?
Get it all.
Cool. Okay, so a function's a thing that takes inputs and outputs, right?
Yeah.
Okay, so in this case, my function is this little box of numbers. How that acts is not super, super important right now. The thing I'm trying to get is that that thing takes 2 by 1 vectors and turns them into other 2 by 1 vectors. So usually this is labeled, what's the set of inputs called usually again? Yeah, this is the domain. And the set of outputs is usually called the range. So the little bubbles here, right, are just pictures that I'm substituting in for the idea of a domain, all the inputs, and the idea of the range, all the outputs. So this thing takes inputs to outputs, and specifically it does that by taking intersecting points and turning them into constants. So it takes an xy point that I specify and turns it into constant. Right, that's really this, right? I specified an xy. I'll do this, I'll get some constants out. If I ask the other question, right, here are the constants where they intersect, that's me wanting to backtrack. Okay, see that? This direction, forward, that's an evaluate question. The backwards question is a solve question. Do you want a simpler example of an evaluate versus a solve thing?
Yes.
Yeah, okay. Let me give you that in a second.